This is a question from the AddMaths book. It's on page 211, chapter 10 on integration, exercise 10E, question 3. We've got to find the area of this shape ultimately in the question, but the question is broken down a bit. We've got three curves, and we've got to identify first of all which curve, the curve OA, AB or OB, is each of these three equations down here. So let's look at that first of all. This one, if I multiply the brackets out, I will get x squared plus 3x. It's a quadratic equation with a positive x squared. So it will look like that. It's that sort of shape. And when x is 0, the value of this is 0. So we know it goes through the origin. So it's a happy one going through the origin. That has got to be the curve OA. This one, again, it's a quadratic, but it's got a negative amount of x squared, so that's going to be a sad quadratic, that sort of way up. When x is 0, the value of that is 0, so y is 0. It also goes through the origin, so that is going to be this one here. The OB is part of a sad quadratic, so that's the curve OB. Final one, again, it's a quadratic, a positive x squared, so it's that sort of shape. When x is 0, that bit 0, this bit 0, y will be 9. So it goes through the y-axis at 9. Well, this bit of here could be a happy quadratic, which cuts the y-axis at 9. So that is the curve AB. The next part of the question, we've got to find the coordinates of A and the coordinates of B. The coordinates of A is where the curve OA and the curve AB are equal to each other. It's where they meet. So to solve this next question, I'm going to put the equation for OA and the equation for AB equal to each other. So I'm going to write down that bit, which is OA, and this bit, which is AB, equal to each other. Because they're both equal to y, they're both equal to each other at that point. So we're going to write down x plus 3, the equation of OA, equals x squared minus 6x plus 9, which is the equation of AB. And now what I've got to do is solve this equation. If I multiply out on the left-hand side, I get x squared plus 3x. Whenever you get a quadratic equation, you want to try and make it equal 0. But let's have a look. Is this a quadratic? I can take x squared off both sides straight away. And if I take x squared off both sides, I'm left with 3x is minus 6x plus 9. So actually, when I solve this, I don't get a quadratic. Just need to solve the equation here. If I move this minus 6x to the other side, it will become a plus 6x. So I have 3x plus 6x equals 9. Well, that's 9x equals 9. So if 9x equals 9, that means x equals 1. So at point A, x equals 1. Now I need to find out what y equals at that point. Well, both of these things here are equal to y. So if I stick x is 1 into here, if I do a substitution, I'm going to get 1, and 1 plus 3 is 4, and 1 times 4 is 4. So I'm going to get when x is 1, y is 4. So the point 1, 4 is the coordinate of A. So I'll go up to my diagram, and I can put in A is the point 1, 4. Now for part B, or rather for point B, I've got to find B is where the curve OA and the curve OB meet. That's where OB, I may have said the wrong one a minute ago, it's where the curve OB and AB meet. These bottom two here. So I'm going to write them equal to each other to find their point of intersection. So I'm going to write x minus a quarter x squared equals x squared minus 6x plus 9. So to find B, I'm going to put equal to each other x minus a quarter x squared equals x squared minus 6x plus 9. Let's solve this equation. So I've got x squareds on both sides. I can't just cancel them out. It's not an equal amount of x squareds on both sides. So most of the x squareds are here. So I'll keep that x squared there. I'll bring this minus a quarter x squared over here, where it becomes plus a quarter x squared. I'll leave the minus 6x where it is. I'll bring the x across, where it'll become a negative over here. I've still got my plus 9, and that's equal to 0. Any quadratic equation you want to equal to 0. So I've got 1x squared plus another quarter x squared, which is 1 1/4, or 5 over 4, 5 quarters x squared, minus 7x plus 9. I need to solve this equation. I don't like the fraction there. Times everything by 4. 0 by 4 is still 0. Times this by 4, I get 5x squared. It's 5 fourths times by 4 is 5. Take away 28x plus 36. Now this I want to try and factorise. It's the easiest way of solving it. It will have come from two brackets multiplied together. The only way to get a 5x squared is a 5x and an x. Now, to get my 36, I want two numbers that multiply together. I could have 6 and 6, 4 and 9, 3 and 12, 2 and 18, or 1 and 36. To find which pair I need, one of those numbers in a pair will have to be multiplied by 5 and combined with the other one to give me 28. Now you can work through these. If I times one of those by 5, I get 30. 30 and 6 I can't get 28 from. If you work through them all, it's actually this one down here. If you times 2 by 5, you get 10. 10 and 18 gives you 28. So now we just got to work out which goes which. I said the 2 had to be times by 5. The 2 has to be times by 5. So the 2 has to go in the bracket where the 5 isn't. So that eventually they'll be multiplied together to give me 10x. If I put the 18 there, multiply those two together, I will get the 18x. This plus sign tells me both signs are the same as that. So when I factorise it, that's what I get. If you multiply it out, you can check. So I factorised it. That means either 5x minus 18 equals 0 or x minus 2 equals 0. The x minus 2 equals 0 is nice and easy to solve. That means x is 2. This one over here, it means x is 18 over 5. And 18 over 5 is the same as 3 3/5. So there are two solutions. Well, this one must be the 2, because they're going to meet again over here somewhere. So B, x must be 2. Now I need to find the y value to go with it. Well, these are the equations I've been solving here. So if I look here and put x is 2 into there, I get 2. Take away a quarter of 2 squared. 2 squared is 4. Quarter of 4 is 1. 2 take away 1 is 1. So the y value there is 1. So back up here, I know B is at the point 2, 1. So I've finished the first two parts of the question. I've now got to go and find the area, and I'm going to start a new video file for that one. So if you search for a file, same name you've been looking at, but with part 2, then we'll get the rest of this question done.